My name is Wendy. I'm a digital services technician here at Richmond Public Library and also a co-organizer of Coding Coffee. Thank you so much for coming out tonight. Super stoked that you're all here. What was I going to say? Oh yeah, so we've just finished the mingling portion of the evening. So hopefully you all got some coffee, got some donuts. Now we're gonna go into the talks, and we have 3 amazing speakers lined up for you tonight. After each talk, there'll be a short Q&A period, and then more mingling and coffee and donuts after that. So a couple things before we get started, just a couple of housekeeping items. Washrooms are up the stairs on the 2nd floor, down the hall, and then to the right. Or you can just exit the library, turn left as well. I think those are actually closer. Also, this talk, this meetup is being filmed or recorded in the back, so if you have any issues about having your photo taken or being recorded, just pull me aside and talk to me. We can figure something out, I'm sure. One of our speakers just raised his hand. So yeah, without further ado, our first speaker is Deeth, and he's going to talk to you about how to make a fully featured website without writing a line of JavaScript.
Alrighty. So, and when I say without writing JavaScript, how many people here are familiar with HTML and CSS at all? Good number. And keep the hands up. Of those people, how many are, put your hand down if you're not comfortable with JavaScript? About half. About half. Okay. That's actually what, so Leah Veru is the person whose work I'm basing a lot of this on, and that's from a survey she's found that that's true of about half the web developers that are comfortable with CSS and HTML are not comfortable with JavaScript. So that's where a lot of this comes from. And when I say you're not writing a line of JavaScript, it doesn't mean you're not using JavaScript. It means that the libraries you use don't require you to write additional JavaScript on top of the library. So you don't have to write a bunch of config code, you don't have to write a bunch of calls. And this is my about me, so this is where I'm coming from on all of this. The third tweet here, one of the creators of Ember decided he wouldn't let that stand, and we got in a drunken back and forth on Twitter. I was drunk, I don't know if he was, but his point was that basically you have to have this incredibly huge framework in order to manage the back button. And to me, that's not a reason to write a framework, that's just a cry for help. We need to get the browsers better. All frameworks are temporary. Frameworks are putting into place what we don't have in the browser, what we can't do yet. And so a lot of the things that you can do with Angular and you can do with React and you can do with Ember are being built in slowly, to be sure, but they're slowly being built in as web objects and other standards. And we saw this with jQuery. Most of jQuery now has moved into the browser. So Leah Veru, she wrote back in February, this article called HTML APIs, why they're good, what they're and how to design a good one. And it was going over these basic things that I'm going to talk about. And then in May, she released an entire framework based on this called Mavo. Which I'll show you a little bit of. And so that's kind of incredible. But yeah, so the idea here is you don't write a lot of JavaScript to write your app. You write your HTML, you write your CSS, you style everything nicely, and then you insert some attributes into your HTML so that the library that you load can find hooks. So you mark either with a class or an attribute or even with a CSS variable, you can mark the bits of your page that need to become dynamic and that need to come to life. And Mavo will do this with it'll turn static elements into lists, it'll turn data into storable data. It'll actually hook up a storage backend for you, whether it's localhost or Firebase or another backend. So you can get on with your work and not struggle with writing JavaScript for it. And so in addition to marking the points where your live parts of your page start, you can also write your configuration bits as attributes. You can, if you have several pieces of live code in your page and you don't want to write the same attributes over and over, you should be able to move them to a higher element in the page that they all inherit from and use the inheritance. Likewise, if you have global settings, you should be able to put those on the HTML or the body tag, or even in the script tag that you load in the library, and have those be discoverable by the library. And you can also, then the key to all of this is then to write good docs so that your users know where it's legal to put the attributes and what attributes to use and what effects they're going to expect from them. So this is a Mavo app before adding Mavo. So this is just a really simple bit of HTML. You've got a main section, and in that you've got a header that says I've got 0 tasks done out of 1. And the 1 task is here. So we've got a checkbox and 1 item that says do stuff. So you can imagine if we extended this list item over and over, then we would have more and more items in the checklist, but we don't want to do that. We don't want to write that out. We just want to make it happen. So this is the after. This is now an application. This is a to-do app that functions, stores its information, you can reload it, it retains things over time. So what have we done here? So MV app says this is the live part of this page. Pay attention to this part and make it active. MV storage says we're going to store all our data in local storage. We could just say Firebase or GitHub, and we could store it elsewhere. MV mode is edit, which we'll see later. It's just telling the application that it's in edit mode. We replace our 0 with count of done. But what's done? Well, down here, we said this checkbox, its property is done. So it's a count of how many checkboxes have been checked. So that's how many done out of count of tasks. Well, what's a task? This whole line item is a task. So the more line items we have, that number will get automatically inserted here. So it'll keep the count of how many total items there are and how many of them have been finished. Now on the line item itself, besides having a property of task to give it a name for the data, it has MV multiple, and that just says this is a list. This is a template for a list. Make more of these. And so let's see what that looks like. With some styling, you see it's just CSS. Now 0 done out of 2. We've got a checkbox. We've got a task title here is just fill in, add task. You can hit a plus, you can move them, you can delete them. It's a fully functional app. So, lines of JavaScript, 0. So, this is just the review here. You mark it so you can find, your library can find the bits of code that you need. You minimize how much init markup they have to do. So if you, for instance, in the to-do app, it needs buttons, it needs a bunch of buttons, it needs a dragger to move things around. You don't make the HTML author create all of those first. Your library, when it's imported, does all of that. So the guidelines that she wrote in the first article were, as a JavaScript author, creating libraries for people to reuse, how can you make it easy for them to reuse? And then the framework is based on that. It's a whole tool based on those abilities. And the other thing that she had here, so the mark app.io is a whole list of library is written in this style that you can bring into your web applications and just use by dropping them in, putting a little extra markup in your page, and having them just work. And then Mava is an entire framework based on that principle. So again, your settings can be attributes, they can be class names, they can be CSS variables. There's pros and cons for all of these. All of them, though, can be inherited. You can search up the DOM tree for them. For global settings, put them at the top of the page or somewhere that in your documentation, you tell people that that's where they can expect to find it. This is my friend Roland, who took all the pictures that I've used here. And I think we still have some time for questions. Yeah.
So how would you make like an API call and like render a list of items based on like the data received from some API call? So let's say you want to display a list of all the pocket keys in an account. You make an API call to grab the list and return to the variable key. So how would that look like?
So there are some libraries for doing basic Ajax calls. And so you have an attribute that lists the URL you want to return data from, and another attribute that says where that data gets fed into, and probably what shape it takes.
So would it be the same if you wanted to post data to some data store, or if you want to make API call?
So hosting has actually been, the original way to post things was already declarative in HTML. We do it so much through Ajax now, we forget that the web can do that by itself with HTML. I haven't used the declarative API for Ajax, but I'm sure it can also be used. Any other questions? Thank you, Wendy, and thank you for having it. And while I've been talking about Leah Veru, while I was doing my slides and doing the research for this, I saw that she had a new book out. So I will plug that for her. CSS Secrets. I haven't started it, it just arrived today. It looks good.
Okay, hi, I'm Robert, and I'm going to talk to you about randomness is not equal to, randomness is unfair. Now, first off, my background, just to give you a bit of an idea of where I'm coming from. Primarily I worked as a technical artist for a lot of different companies, Electronic Arts, Rockstar Games, Radical, Take-Two. I've also worked for a whole bunch of other small independent studios, so a lot of game development background. Lots of successes, lots of failures too, lots of stuff in between. And it's always struck me as something that we're constantly facing this challenge in production and in life, and it seems society at large, we have a lot of random events, it seems like. And I'm using random at this point as kind of like a placeholder for unpredictable. So when I say random, I'm not necessarily talking about pseudo-random number generation on computers. We can talk a lot of technical stuff about that, but I want to try and avoid being all technical about things. And for the demo the demo I'm going to show you today to illustrate some of the points I'm trying to get across is in and of itself using a pseudo-random number generator, so it's not truly random. For those of you who are technically aware of what that means, I'm sure you can appreciate what I'm saying. For those who do not, it basically is that computers don't give you truly random numbers. But it's good enough for purposes of what I'm going to do anyway. And I'm going to apologize in advance because literally minutes before you all showed up, I was trying to fix some bugs in my demo and a few bugs. But the data it shows, for the most part, aside from a few rendering gaps, is accurate. Okay, disclaimer out of the way. So what do I mean by fair? throw this on the screen, make sure that's all working correctly. That's the right one. So what do I mean by fair? I mean by, or unfair, as in equity. Not necessarily like an even chance. Like when we go and we play a game like, or most any game of chance, we expect a certain fairness of cards being handed out, 52 cards, a chance of getting a given card, 1 to 52, and combinations, you can work out the maths from there to figure out what your odds of getting a certain combination of cards. Those are like probabilities. That's perfectly fair. That's not the fairness I'm talking about. The fairness I'm talking about is whether or not we can get a fair, equitable distribution based on randomness. And there's an important distinction, I think, because when we think about the way our economies work, biology, or the universe at large, we don't have a fair distribution of stuff. We never have. And we seem socially as beings to try and move towards a point of having things be more fair for everybody. Equality. But it seems that the universe abhors equality. Demonstrate that right now. Assuming this works. If not, I'll trust it. Okay, so what we have here is something that's not playing. Quick play, don't crash, don't crash, don't crash, don't crash. Let's get started. Oh yeah, goodness. So what we have here is just a quick little sort of a number line, illustrating values amongst a set of points. Now, part of the goal of setting out here is to actually have a bunch of other things that would make this go a lot faster. So forgive me as I poke around on this to get this set up properly. So what we're going to show here now is just randomness. Okay. There we go. What we see here is the initial set of values that originally were there being randomly handed off by a certain amount to another node on this line, or another point on this line. And we're seeing values expressed through the length of the bar. You can very quickly identify right away there's some peaks. Curious detail about this that strikes right away. Those peaks tend to be quite resilient, tend to hang around for quite a while. Now, over long periods of time, they will go to zero and someone else become a peak, as you can see. And in fact, I can speed up the simulation to illustrate this. And of course, that part's not working, so look manual. Let's speed this up. Go fast. Okay, let's turn on the car where it speeds it up. There. Okay, now it'll go fast. Alright, so now you can see this almost looks like we're listening to some sort of dubstep music or something, but this is where those peaks, they're lasting for a period of time, they're fairly persistent, but they will go away, and eventually everyone gets their turn. But the interesting thing about this is that, yes, over a long period of time, you do get this nice even distribution if you were to average out and normalize all these values over a period of time, or a long enough period of time. But us as people, we don't last that long. Most things that we know of, in fact, the entire universe seems to be only around for so long. So the chances are you're going to see something at any given point in time, or a period of time, that looks more like this. Stuff that is, and a lot of stuff that isn't. So let's sort this differently, and let's look at this from highest to lowest. Highest to lowest, yeah. So right away, what started as a value of 1 for all of them, all of a sudden we have this curve. And the larger we make these numbers, the more distinct that curve becomes. And this is just randomly distributing values around. And we're just seeing the weighted values of the results, stacked and seeing where things are at. Anything that's not blue and next green and going darker than green has less than what it started with. It's inequitable. Unfairness, depending on how you define unfairness. So I'm going to switch this to, let's see if it works. Oh, hey, it worked. Okay, just need a second here to roll this around. Because I'm going to make this into now a, instead of being, sorry, I still had work to do on the controller stuff. This is now going to become something where we have a lot more nodes in the network, and instead of being a non-localized distribution, randomly, in other words, randomly picking any given other node in the array, it's now going to go into a two-manifold. Basically, every neighbor is going to be able to share with only its neighbors, and so on. The boundaries of this will flip those values over to the other side and on all ends. And so we'll put this back to that. Sorry, lots of. So now we're seeing a very large sample. We're going to reset the field. We have all sorts of noise. And these guys are now sharing values with one another. Yeah, two-manifold solution in this case. And we have a lot of peaks, a lot of valleys. It's kind of insane. And then we're going to organize it. We get to see something really interesting. If I can control this. Okay. Look at that. Yeah. Quite an interesting curve we see in what those values look like. And again, this is just randomly distributing values to its neighbors. So we get different topologies, not topologies, but different shapes and what those numbers end up looking like. So why am I talking about this? Why is it unfair? I mean, well, as I said, I come from game development. I spend a lot of time trying to come up with abstractions on complex real-life stuff and how it works in a game. You know, simplifying it so we can kind of grasp some of these ideas. And randomness always comes into the question, and how this applies like things like, if you play like Dungeons and Dragons or in the game you're like rolling dice, that first time you spend with building a character sheet, those numbers that you roll are going to affect how likely it is that you're going to survive going on further on with the next random opportunity, and the next random moment, and the next random moment. And they all stack on one another. And what you kind of get is a curve that's kind of like this. You get these couple players that end up having these really lucky rolls near the beginning, and they have this tendency to more likely survive, versus a majority of players who just kind of rolled a 1 on a 20, and you know, they got their butt kicked. Okay, those of you that don't play Dungeons and Dragons, it's like lotteries. Most people don't win the lottery. There's a lot of examples I could get into, but I will not do that right now unless I want to. But anyways, I find this fascinating from the standpoint of the fact that anything we look at for developing abstractions and tools, randomness, it has to be seen for what it is. It's not fair. And when we're making games, or when I'm making games, or when anyone's working on any other systems that have to rely on random numbers being used to simulate something, we need to account for it. And honestly, I think it tells us a lot about what our economies look like. When we talk about the inequity in the world around us, you know, there's a certain random distribution that's going in play there as people hand money to one another, neighbor to neighbor, on how it affects. Yeah, and that's pretty much the point. I wanted to show so much more in this, but it's not quite ready, so I hope you'll forgive me for that. But anyway, that's pretty much the bottom. Yeah, don't get any questions. Please. Yeah.
Are you saying that there was a pattern found in random selection?
A pattern found in random selection? Well, not so much that there's a pattern in that patterns are predictable, right? So, no. But there is a distinct pattern that emerges from random events. And when you carry those random events forward from moment to moment to moment, they impact one another because there's causality. There's a contiguous set of sequences that lead to a result. And from there, we can start to see those patterns emerge from those initial random states that compound on one another. So in that sense, it's kind of the other way around. And that's where I think that we can, take a look at a lot of the world. And when we make arguments to people that are like, someone's done really well for themselves, you know, and people dismiss it as all hard work. Yeah, there is a lot of hard work, but there's also a lot of uncontrolled circumstances leading up to it. And there's just, the entire universe seems to have all of these moments that we didn't really have any control over. And we can kind of treat as random events because, as I said at the beginning, it's more about stuff that we just don't know how to predict. And they all build on one another, and you could even get in arguments of quantum mechanics and physics even, like, and how things come together and be what they are. Yeah, so patterns from the random noise. Yeah. Hope that makes sense. Anyone else? Nope. I feel like I forgot something. Okay.
So automating with C#. Today I not only want to talk about C#, but I kind of want to open up the subject about automation. So first thing, automation currently, there's negative connotations to it. So people think of it as lots of jobs, or lots of jobs, or there's decreased personal interaction. You're always facing a screen. And then a lot of things would become generic or cookie cutter. So there's been a lot of negative talk about it. But I kind of want to talk about why I automate personally. So I automate things that are tedious, that need repetition or need to be repeated a bunch of times, or something that you don't want to repeat a bunch of times. So either or. And you want to make the data human or error-free. Because right now, a lot of data, there's privacy concerns. So if you don't automate, then there's a lot of human interaction with this data. So we want to take it away. And the last part is cost savings. So sometimes there is cost savings. However, in certain circumstances, there's not. Because you need to still train a person. You need to maintain your code, and you also need to maintain equipment, if any. So the reason I did kind of a talk about Excel and C#, because everybody knows Excel. Excel has good features such as, there's built-in filters and graphs. It's a good presentation tool, and there is a maintained library by Microsoft. So those are the kind of good things. And then C# kind of just couples well with Excel, because it is also Microsoft maintained. And it's, the other reasons I like it is it's strongly typed. And I've been using Python for a very long time now, and hate that it's not typed, so it's kind of nice to come back to it. And there's no check exceptions, and also you can make an executable console application quite quickly. So I also have some JSON data. So let's say if you have So I got this data from Open PPE, or Vancouver Police Department's crime data. And today we're going to query it on the neighborhood and the crime type. So can we see this? The neighborhood and the type of crime. Let's do that. So, and I'm not going to go through how to parse JSON, but there's some links online that you can try try out. They're pretty easy to use, and C# fully supports it. So let's walk through the Excel API. So I'm gonna try to do. We're gonna try to automate it 2 ways. So first thing we're gonna do is just try to put the Excel data onto the sheet. So the first thing that you have to do is open the Excel application and just ignore the red parts. So I just haven't imported the libraries in yet. So first thing you would do is go to the library, export an Excel application which opens an empty Excel window. After that, you would have to open a workbook. And then you want to open a workbook. So you want to say, open my workbook, and there's a part.
Did you make the text bigger?
Okay.
Maybe like a font setting.
Getting bigger than this? That doesn't work. I think it's control scroll up. No.
Is it on the bottom corner? Because these things says 110% on the bottom corner here.
Hey!
Troubleshooting.
That's too big.
No, it's perfect.
150.
Perfect.
So should I start this again?
Yes, please.
So, okay. So the first thing you want to do is open the Excel application, which just opens a blank Excel window. And you want to do that using the library. So I'll just pop it into the library. I had all this ready to go, but Windows decided to restart it. Here's the application class, and this is the Windows library, and I'm going to use the interrope.xl library, so you can just Google interrope.xl. And this is the function we're going to use, so xl.application. Right here, it's the automation to start launching your Excel app. The next thing you want to do is open up a workbook. So when you open up a workbook, so right here is to open a workbook, and there's built-in Excel templates that are made So there's a macro kind and a default one. So I just use the default one, which is a normal Excel sheet. And then after that, you want to add a worksheet to it. So when you actually open a blank template workbook, it does add a sheet on its own, but I just thought it would be good to add my own sheet. So I added an own sheet. That way I can name my sheets. And lastly, you want to add something to the cell. So you want to say, for this cell, add this value to the column. So that's kind of the overall high level of how to integrate the Excel to your project. And after that, I'm going to take my JSON parser, parse my data out, and just going to show you this. Look at it. Richmond, fill in data. This data is about 4,000 lines. So this whole thing took about maybe 10 to 15 seconds. I don't remember counting. But usually if a person was to enter that in manually, if ever, I don't think they would. If you were to enter any manual data or get some data from a database, usually what you would do, it would take maybe a couple of hours or maybe a couple of days. So let's try to make it more interesting. So the second goal I set is to make some sort of statistics. So what I did was I thought it would be a good idea to find out where would be the most popular crime and what's the most popular crime. Because I thought that's kind of interesting to know. And I'm just going to calculate that out. If you see. So while it's calculating this map out for us, we'll jump back into the presentation. And I just kind of want to provide some tips at the end of it. So first thing is to do, whenever you're trying to automate this first thing, try it manually. If it doesn't work manually, it's never ever going to work using a computer. Also, whenever you're trying to run it, make sure at that point you're making decisions on what language I want to use. Do I need to have any other equipment, or what kind of maintenance, long-term maintenance? Because after a while, if you're integrating multiple applications into it, you'll end up wanting to maintain it. And if those applications end up changing, you'll have to change your program. The second thing is try to pick a good language. C# is a good language. There's a lot of support for it. There's lots of libraries. Like in this example, I integrated Excel and JSON. There's other instances where I can implement other applications, and it's easy to do, or you can learn quickly. There's a lot of people doing it. And the last thing is, whenever you're going to automate, at the end of the day, someone's going to ask you, can you make it faster? So you end up wanting to pick something that you can parallel process. C# has a built-in parallel processing, which is awesome. And FYI, if you're ever writing to an Excel, you can only write once, so you cannot parallel process or writing. So let's see, this stats is done. And from that, we can see the most popular crime, this custom rated tool, and the most popular area is Central Business District, which is around Gastown and Hastings, like Google it. Right?
Good to know.
Yeah, so try not to hang out there. With your car. You can go alone. Anyway, thanks a lot.
APIs where I can open an existing workbook and worksheet and fiddle with the data that's already in it?
That guy's not in solve I haven't done it myself. I trust Steve.
It
Okay, yeah.
it has a very rich API.
Yeah, okay, cool.
Any other questions?
Can the Excel API make graphs?
Yeah. There's a whole different part of that that I haven't looked at yet. But there's a graphic API. Everything that you can technically do in Excel, there's an API. Awesome. Thanks so much. Thank you, Asha.
And thank you for being patient with our equipment situation. So that concludes the short talk portion of the evening. You're free to stick around, mingle, have some more coffee, have some more donuts. I also wanted to mention that some of you may have replied on the Code and Coffee meetup page. And Anna's going to help me out right now. But some of you may have also replied yes on our tech meetup page. So Richmond Public Library now has a tech meetup. So if you are interested in more tech meetup events here at the library, please join the meetup, and I'll keep you posted on upcoming events.